Glad to be on another section of our presentation today. We'll be solving problem on trigonometric functions. So it's our YouTube channel, Dolo Escobar YouTube channel. Kindly subscribe to this channel, like and share our video. The channel is here to help you up in the areas of mathematics. Most of our videos have a lot of great contents. So subscribe to our channel, like and share our video. Click on subscribe such that every time we upload new video, you will follow up. We are also available to partner with organization, individual who like wanting us to help in the area of mathematics, offer tutorial both national and internationally. We are available to that. So stay connected as we go through our problem solving. Like I said, it is on our trigonometric functions, so it is a very easy method that we're going to be using today, and you already enjoy following our video. Stay connected. What I'm about to do now is to analyze this entire problem. It is very easy to start. The first thing, to find the 6 trigonometric functions without the use of calculator or table as the question demands, the first thing we're going to do, we're going to use the equilateral triangle. And knowing that the equilateral triangle is a triangle with 3 equal sides, so which considers 60 degrees of each angle, because 60 degree plus 60 degree plus 60 degree or 60 degree times 3 angles will just be equivalent to 180 degrees. So that's the concept we're going to use. Until then, what we are about to do now, we are about to list the 6 trigonometric functions. As we list the 6 trigonometric functions, go to our equilateral triangle, use our brain, derive the values. Now we can quickly and easily find the 6 trigonometric functions. You can call it 6 trigonometric ratios or 6 trigonometric function. It's the same. So now, here we go. The first trigonometric function is sum. So we got sum. Then we put a parenthesis and put an abbreviation. So we call it SRN, sum. 2, we got cosine. We got cosine. So we are going to place a rep beneath sum. So we got cosine. So we abbreviated to say cos. 3, we got tangent. T-A-N-G-E-N-T. Tangent, we abbreviated tan. Then 4, we are leaving a space here for our solution. So 4, we have cosecant. C-O-S-E-C-A-N-T. Cosecant, we put our parenthesis will be is cosec. C-S-C, cosec. 4, we have 5, we have secant. S-E-C-A-N-T, secant, and the abbreviation is sec, S-E-C, sec. And 6, we have cotangent, the C-O-T-A-N-G-E-N-T, and the abbreviation is cot, C-O-T. So we have listed the 6 trigonometric functions. The reason why we do this, one that asked, we did it to make it easy so that when we are solving our problems, when we are finding the degree of each of them, we can just place it back here. So what we're going to do is we put 30 degree and 60 degree and just pull that back. So it is a very important, very easy method. So let's follow up. We're going to make this problem very easy. So for here, for sum, so we just indicate here 30 degree. So that's how we're going to do our indication. So we're going to pull the values of sin 30 degree here, sin 60 degree, cos 30 degree, or 60 degree, tangent 30 degree, tangent 60 degree. We'll do lengthwise here. So this is just what we need. So same, so that 30 degrees, and that's 60 degrees. So the same, they already indicate this value will come right there. So after we have done with this, we now going to draw our equilateral triangle. So now we draw our equilateral triangle here. So we said equilateral triangle have 3 equal sides. So it means that this is not drawn to scale anyway. So this is 60 degrees. 60 degrees. 60 degrees. So the length right here we say is 2, 2, and 2. So if we bisect this triangle, that means we divide the triangle equal to 2. Bisect this from here. Here. It means here we have 30 degrees. Here we have another 30 degrees. So it means the distance from here to here is 2. Here is 2. Level from here to here is 2. Here is 2. Also from here to here is 2. Here is 2. So since we have bisect this, it means that there's a distance from here below. We are already bisected. So what we do this, come here. It means the distance from here. When we did the division is 1. Also the distance from here is also possible 1. After we have done this, let's consider one of the triangles from this diagram. So we already have 2 triangles from this one triangle. So we bisected because our goal is to have a 30 and 60 degrees. So if we consider one of it, so here we got 60 degrees, 60 degrees in this corner. Here, as we have bisected, we got 30 degrees already. Here we got 30 degrees here. The distance from here is 2. The distance from here is positive 1. And the distance from here, which is the height or the opposite, we don't know. So put question mark, or we use the variable x because we want to find the unknown. This is really what will help us to be able to find the 6 trigonometric functions. So what we are about to do next is to use the Pythagoras approach, the Pythagoras theorem, to find the unknown here. Now, according to Pythagoras, he said that the square of this hypotenuse, this is hypotenuse, we abbreviated, this side is the opposite, OPE, this side is the adjacent, we abbreviated. So the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent side. So it means that the square of the opposite will be equivalent to the square of the hypotenuse minus the square of the adjacent side. So this means that S square will be equal to the hypotenuse is 2 square minus 2 square minus the adjacent is 1 square. So to solve this, we say S square will be equal to 2 square is 4 minus 1 square is just positive 1. So it means S square will be equal to 4 minus 1 is positive 3. We want to get rid of the square on x. We only need x. X don't need to be in square form. So we take the square root both sides. The square root both sides. This square we cancel out this root. We left only with this, so it means we left with x here. X will be equal to the square root of t. So it means that this on the lower side now is what? is the square root of t. Let's separate this to make our problem very easy. What we are about to do this entire, let's take this a right angle triangle, because after we bisected this equilateral triangle, now we result into a right angle triangle. So let's take the right angle triangle carefully and bring it here. For the diagram we got, here we got 30 degree. We got 30 degree up here. 30 degree. Here we got 60 degree. This is right angle sound. So here for the diagram, the hypotenuse is 2 with the hypotenuse. Here the adjacent is positive 1. Positive 1, the adjacent. This is the opposite. And the opposite from what we got is the square root of 3. So let's put in the circular form. Let's indicate. This is the diagram we're going to use now to find each of our values. So we now come to sum of 30 degree. The sum of 30 degree, looking at this diagram, this is sum. Sum 30 degree, note that for sum, if we are considering sum, for sum here, for 60 degree, this is opposite, hypotenuse, adjacent. For sum, the opposite and the hypotenuse position will change. So for sum 30 degree, for this 30 degree, this side will be opposite. And for this sum 30 degree, for 30 degree, this side will also be adjacent. And we get what I'm saying. If we are considering 30 degree now, it means this side that touching 60 degree will be the opposite for 30, and this side that is opposite to 60 degree will be the adjacent, because this side is touching 30 degree. So this simply means that the length that is touching the angle is the adjacent, and the length that is away from the angle but has the right angle and simple, it means that that length is the opposite side. So for sum 30 degree, we will have this will be the opposite, and this will be the hypotenuse. The hypotenuse will be constant. Then for 60, the length that is touching 60 will be the adjacent. For 30, the length that is touching 30 will be the adjacent. So for sum 30 degree, we have the opposite side or the hypotenuse. So that would be positive 1 over 2. This would be 1 over 2. Then we come to sum 60 degree. Then for sum 60 degree, the side touching 60 degree is the adjacent. We are not looking at that because it's opposite or hypotenuse. So for 60 degree, we got the root of 3 over 2. So for 60 degree, we then put the root of 3 over 2. So we done with sum 60 degree, and we come to cosine. So for cos 30 degree, we come to cos. Cos is the adjacent, that's the side touching the angle 30 degree, or divided by the hypotenuse. So what the adjacent side to 30 degree, the side touching 30 degree is the square root of 3. So it would be the square root of 3 or divided by 2. So for sum 30 degree, for cos 30 degree, we have the square root of 3 or divided by 2. So this will be the square root of 3 divided by 2. Then we come to cos 60 degree. Cos 60 degree is the adjacent or hypotenuse. So the adjacent side here is, the side touching 60 degree is 1, and the hypotenuse is 2. So it will be 1 over 2. So it will be 1 over 2. So we can separate this to indicate it. 1 over 2. So we have our separation. So it's the same from the separation down here. So the same here. We want it to be very easy. Alright. So after we are done with this, now we can go to tangent. This diagram is very simple. So the tangent of 30 degree here, tangent of 30 degree is the opposite over the adjacent. So tangent of 30 degree, for 30 degree, the opposite is 1 down here. and this is adjacent, start touching 30 degrees. So it will be 1 over the square root of 3. And 1 over, so when we say 1 over the square root of 3, so multiply square root. So it will just be the square root of 3 all over 3. So tangent 30 degrees will just give us the square root of 3 all over 3. So this will give us the square root of 3 divided by 3. Then we come to tangent 60 degree. Tangent 60 degree is opposite 60. This is the opposite side of 60 degree. Like this is the root of square root of 3. It will be the square root of 3 all divided by 1. And the square root of 3 divided by 1 is just the square root of 3. So tangent 60 degree here will be the square root of 3. The denominator is 1. It's not supposed to be indicated. So we come to cosecant 30 degree and 60 degree. So cosecant 30 degree from this diagram, we should understand that it's very easy. Now we don't really need to solve problems. The opposite for sine is cosecant. The opposite for cosine is secant. And the opposite for tangent is cotangent. So what we are about to do in this experiment, rather than solving problem and other thing, we just come and see sine 30 degree. Since sine 30 degree is 1 over 2, the opposite for 1 over 2, which is cosecant 30 degree, will just be 2 over 1, which is just 2. So that's how we're going to analyze it, and it's very easy. So the most difficult thing is to just firstly solve sine, cosine, and tangent. As soon as you have your values for them with respect to 30 degree and 60 degree angles, then you can just reciprocate. When you come to sine of 30 degree, since sine of 30 degree, cosecant of 30 degree is the opposite of sine of 30 degree, you just get the value and find the opposite of it or reciprocate it. So sine 30 degree is 1 over 2, therefore cosecant 30 degree will just be 2. 2 over 1 is just 2. Then now we come back here. Sine 60 degree is the root of 3 over 2. So it means that cosecant 60 degree will be the 2 over the root of 3. But 2 over the root of 3, mathematically, the radical sign is in the denominator. So mathematically we got to apply our mathematical induction. So therefore we multiply the denominator, the root of 3, to both sides. So this will be 2 the root of 3. The root of 3 times the root of 3 is just positive 3. So it means that cosecant 60 degree will give us the 2 the root of 3 all divided by 3. So we got down here 2 the square root of 3 all divided by t. So let me write the 3 good on the back. So this is cosecant 60 degree. So this is the opposite for sine 60 degree. Then we come to secant. Knowing that secant is the opposite for cosine, so we say since cosine 30 degree is equal to the root of the square root of 3 all divided by 2, then this means that secant 30 degree will be the opposite of cosine 30 degree. So in this light, since cosine is the square root of 3 all over 2, therefore secant will be 2 over the square root of 3, and 2 over the square root of 3 we just solve back here. We just got 2 the square root of 3 divided by 3. So we don't need to solve ourselves to go deep into problem solving. So we just take our 2 the square root of 3 divided by 3. So this is secant 30 degree. And now, since cosine 60 degree is equal to 1 over 2, and knowing secant to be the opposite of cosecant, sorry, the opposite of cosine. Therefore, we're just going to find the reciprocal of 1 over 2. 1 over 2 is just positive 2. Then we go to cotangent. Cotangent is the opposite for tangent. Since tangent is adjacent over opposite, therefore cotangent will be opposite or adjacent. So it's very easy to understand. So since tangent is opposite or adjacent, that's why we saw tangent 30 degree to be 1 over the root of 3, and 1 over the root of 3 give us the root of 3 over 3. And so it means that for cotangent 30 degree, we will just have the opposite for tangent 30 degree. So since tangent 30 degree is the root of 3 over 3, so the root of the square root of 3 divided by 3, therefore cotangent 30 degree would be 3 over the square root of 3. So we multiply both sides by the root of 3 by the root of 3. So this will be 3 the square root of 3. Oh my God, you get it? All over 3. So 3 the square root of 3 all over 3. This 3 can cancel out the 3, so we just left with the root of 1, 3. So this simply means that cotangent 30 degree will just be the root of 3 as we perform our mathematical induction. So we got the root of the square root of 3. So cotangent 30 degree is equal to the square root of 3. Then we come to cotangent 60 degree. So cotangent 60 degree, let me erase up here so you can see our problem clearly. So cotangent 60 degree will give us the opposite. It is just the opposite of tangent 30 degree. Now, cotangent 60 degree is also the opposite of tangent 60 degree. So since tangent 60 degree is the root of the square root of 3, therefore this is in tangent 60 degree equal to the square root of 3. So this means that cotangent 60 degree will be the opposite of this. So mathematically they have a denominator of 1. So we say it's equal to 1 over the square root of 3. But it cannot stay in this form because the radical sign is in the denominator, so we got to perform our mathematical induction as demanded by radical operation. So 1 over the root of 3, we multiply both sides by the denominator, the radical root of 3. So 1 times the root of 3 will just be what the root of 3. The root of 3 times the root of 3 is just positive 3. So this will give us the root of 3 all over t. So this is the 6 trigonometric ratios. Thank you so very much for following this video. It is very easy to understand. Follow the video, follow the step-by-step approach that I use in the video, and you will really like it. Just know that after you have found your first 3 trigonometric functions, which are sine, cosine, tangent, you have found the 30 degree and the 60 degree using the equilateral triangle, how we derive using the derivation we did. Now to find the cosecant, secant, and cotangent, just find their reciprocal. Because since sine is opposite over hypotenuse, it means that cosecant will be equal to hypotenuse or opposite. And since cosine is adjacent or hypotenuse, this also means that secant is hypotenuse or adjacent because secant is the opposite of cosine. Since tangent is opposite or adjacent, this also means that cotangent will be adjacent or opposite. So this is very easy to understand. So take this video. We have great content coming up. Stay safe and God bless.